Hi everybody, it's Mrs. T again, just coming to you with another review video for one of the questions that somebody asked. This question was about a question that was on an AP exam about KSP with common ion. And just as a review quickly of KSP, if you're talking about something with a KSP, we're talking about something that is slightly soluble. Okay, so for example, calcium hydroxide has a KSP of 1.3 times 10 to the minus 6. So since the calcium hydroxide is a solid, that doesn't enter into our KSP expression, and the KSP expression would be calcium plus 2 concentration times hydroxide minus concentration squared, okay? They both start out as 0 because originally we have just the solid, and then as equilibrium is reached, or I should say when equilibrium is reached, then we have the other ions present. So they both start out as 0. Now, because it's 0 is on this side, this is going to be plus coefficient x, read down to get the equilibrium concentration, which means that the equilibrium concentration when we're putting this into pure water for calcium is x and for hydroxide is 2x. And we plug that into our KSP expression, and when we solve for the x, which comes down here, which is the 0.0069, that x is the molar solubility. So when calcium hydroxide, at whatever temperature this was, I believe this was 25 degrees Celsius, when calcium hydroxide is put into pure water, the solubility is 0.0069 molar. That's the maximum amount of calcium hydroxide we can get to dissolve. But if instead we put it into a 0.1 molar solution where we have calcium ions at 0.1 molar, this was 0.1 molar calcium nitrate, which means that because of the nitrate, it's automatically soluble. Being automatically soluble means that instead of starting out at 0, the calcium ion starts at 0.1. So this goes in as a solid into a solution where the calcium ion is already 0.1. There aren't any hydroxide ions dissolved yet, so that starts at a 0. So this is still a plus x and a plus 2x, plus coefficient x, because of the fact that this side has a 0 on it. But this x, this change, is going to be really small compared to the 0.1. So this kind of a question where we are putting a slightly soluble substance that has a KSP into a solution that already has a common ion, we treat this like a small k, where the change x is neglected. So when we plug it in, okay, when we plug it in to the KSP expression, we don't put 0.1 minus x, 0.1 plus x, we just put 0.1. So it's 0.1 times 2x squared, so which winds up being 0.1 times 4x squared. We divide both sides by 0.1, then we divide both sides by 4, and when we square root at the end there, we wind up getting this, for this particular situation with the common ion already dissolved, we wind up getting 1.8 times 10 to the minus 4. So we can compare the two solubilities, where if we put the calcium hydroxide in solution alone, its solubility was 6.9 times 10 to the minus 3. I just took this and put it into scientific notation. But if we put it into a solution that already has the calcium dissolved, its solubility decreases down to 1.8 times 10 to the minus 4. Because remember, this doesn't have to be x times 2x and the x's have to be the same. It has to be that this concentration times that concentration squared has to give us the KSP. So we already had an amount here. So that amount times this 2x total quantity squared has to equal out to this number. And mathematically, this is the number that we get, the 1.8 times 10 to the minus 4. So adding a common ion will actually decrease the solubility because, again, think about Le Chatelier's principle. We are adding to the products, shift away. We are preventing the reactants from dissolving because of the higher concentration of products. Hopefully that helped. And again, if it didn't, or if you still have any more questions, please just feel free to reach out to me on email or Remind. And also feel free to poke around at Mrs. T Chem Talk on YouTube and see if there's anything else that can help you there. Hope everybody's doing well.